A roof covered in panels looks like freedom. The reality is a power plant you must engineer yourself. Most buyers discover the difference only after the contract is signed. The sales pitch promises independence from the utility. The fine print delivers dependence on weather, batteries, generators, and financing terms you cannot easily escape. This video reveals the engineering and financial gaps that separate a glossy brochure from a working off-grid home. We will open the macro loop now. What does a truly resilient off-grid system actually require? And why do so many installations fall short when the grid goes dark? The Department of Energy defines an off-grid photovoltaic system as one not connected to distribution lines. The household must produce, store, control, and consume its own electricity on site. That definition sounds simple. The engineering is not. The Department of Energy lays out 4 essential design steps. First, determine household loading requirements. Second, assess environmental parameters at the site. Third, source reliable components. Finally, perform a system analysis. Notice that panel count is the 4th or 5th question. The critical first question is what the occupants consume, when they consume it, and how much loss of service they can tolerate. A grid-tied solar system without appropriate battery islanding equipment ordinarily does not keep a house powered during an outage. The grid-tied inverter must shut down to protect utility workers and the grid. Off-grid operation requires equipment capable of operating independently. That includes batteries, inverter charger equipment, controls, and typically a generator or another backup source. Here is the first micro loop. The panels are the longest-lived major component, but not necessarily the whole system. Department of Energy reports from a 2025 survey show that the average operational lifespan of solar panels rose from around 20 years in 2007 to between 25 and 35 years today. In contrast, inverters, batteries, electronics, generators, and ancillary equipment usually have much shorter replacement cycles. A buyer who sees a 25-year panel warranty without budgeting for inverter or control maintenance is comparing one component to the entire system. That mismatch is where the independence illusion begins to crack. The Energy Information Administration shows large regional variations in household consumption. In New England, average monthly residential consumption was 601 kilowatt-hours, with an average monthly bill of $166.48. State-level consumption and pricing differ substantially. This demonstrates why generic off-grid quotes can be misleading. A household using 600 kilowatt-hours per month averages roughly 20 kilowatt-hours per day. Averages conceal the real design problem. A 20 kilowatt-hour daily average can still contain massive power peaks. Electric resistance, heating, ventilation, air conditioning, pumping, cooking, or drying require a much larger inverter and battery discharge capacity. Off-grid living requires solving 2 distinct engineering problems. The first is energy, which is how many kilowatt hours are needed across a full day or an extended period of bad weather. The second is power, which is how many kilowatts must be supplied at the exact instant appliances start up. The Department of Energy distinguishes energy capacity, measured in kilowatt hours, from power capacity, measured in kilowatts. A battery can contain substantial energy, yet still be unable to provide enough instantaneous power for certain large loads. The common enemy here is the panel count trap. Sales conversations often lead with how many panels fit on your roof. Responsible design starts with actual demand data. At minimum, the buyer needs at least 12 months of utility bills if currently grid connected. Detailed interval data showing hourly or 15-minute usage is ideal. Buyers must list every significant appliance, its wattage, daily runtime, seasonal use, starting surge power, and whether its use can shift to daytime. Future loads must be included. These include electric vehicle charging, heat pumps, well pumps, pools, spas, workshop equipment, additional dwelling units, induction cooking, electric water heating, and changing family size. A design based solely on annual solar production can fail during a cold, cloudy winter week with elevated heating demand. Instantaneous power demand can easily defeat an energy-rich design. A home might use 20 kilowatt hours on a typical day. However, it might still briefly demand massive power when a well pump, refrigerator compressor, microwave resistance water heater, or heat pumps start simultaneously. The system may possess enough stored energy for many hours, yet lack enough inverter output or surge capability for that single instant. That is why battery kilowatt hours alone cannot describe whether a system can run a home. Seasonal mismatch makes this worse. Solar generation and household loads move in opposite directions. In cold climates, daylight hours shorten during winter, while heating, lighting, and water pumping energy use rise. Snow can cover panels or create structural load risks. The Department of Energy notes that photovoltaic modules operate more efficiently in colder weather, but temperatures above 77 degrees Fahrenheit reduce voltage. Better cold efficiency does not erase short winter days, storms, snow cover, or high winter demand. Federal experts also caution that even partial shading can significantly reduce power output. The hardest off-grid day is not the annual average. It is the worst combination of low sunlight, high demand, low battery state, and equipment limitations. We have opened the engineering reality. Now we must confront the financial reality. The quote is rarely the true cost. The Consumer Financial Protection Bureau warned in August 2024 that some residential solar lenders mislead homeowners about loan terms, costs, and energy savings while adding markup fees. The Bureau found that dealer fees can increase loan principal by 30% or more above the cash price. Such fees are frequently embedded in the principal without appearing in the stated annual percentage rate. Hidden fees typically range from 10% to 30% of the cash price and can exceed 50%. Dealer fees are rarely shown to the customer, even though they increase the total loan amount. They also make the interest rate look artificially low. That is a direct quote from the advisory issued by the Consumer Financial Protection Bureau. Buyers should require specific answers in writing. What is the cash price? What is the financed price? What is the exact loan principal and annual percentage rate? Are there dealer, lender platform, program origination, finance, or buy-down fees? Is the interest rate contingent on applying an anticipated tax credit to the loan balance? What happens to the payment if the tax credit is not received or is smaller than expected? The federal tax credit caveat is critical. Internal Revenue Service materials explain that the residential clean energy credit is a 30% credit for qualified clean energy property, including qualifying battery storage technology of at least 3 kilowatt-hours. Guidance states that the credit is non-refundable. A tax credit is not the same as cashback at closing. A purchaser must have sufficient tax liability and satisfy eligibility requirements to use it. Buyers must exercise caution regarding current laws and verify official tax guidance on the filming date. Federal Trade Commission consumer alerts issued in August and September 2024 warned about solar scams involving false claims of government affiliation, promises of free solar, and extreme pressure to sign contracts quickly. The position of the Federal Trade Commission is direct. Offers for free or no-cost solar panels are scams. The federal government does not install solar systems in homes for free. Take your time and never sign under pressure. Consider the legal action against Vision Solar and Solar Exchange. The Federal Trade Commission filed a complaint alleging that New Jersey-based Vision Solar, Solar Exchange, and owner Mark Getz violated federal and state consumer protection laws through unlawful telemarketing calls. Regulators alleged that telemarketers falsely claimed affiliation with utilities or government agencies while making unsubstantiated cost claims. The settlement order against Solar Exchange prohibited misrepresenting government affiliation and imposed a partially suspended penalty of $13.8 million. Federal Trade Commission Chair Lena Khan stated in an August 2024 briefing that Solar Exchange made tens of millions of illegal telemarketing calls to people on the Do Not Call registry on behalf of Vision Solar. These enforcement actions represent specific allegations and settlements, not proof that all solar companies engage in similar conduct. However, they expose a common playbook relying on pressure, hidden fees, and exaggerated claims of independence. The core controversy is rarely about whether solar technology works. It is about whether sales representations accurately reflect seasonal generation, battery degradation, generator reliance, load limits, financing costs, tax credit assumptions, permit costs, code compliance, and insurance implications. Responsible installers provide detailed load studies, proper permits, code-compliant equipment, clear service plans, and realistic performance modeling. The Federal Trade Commission advises consumers to research firms, confirm licensing, compare detailed written bids, and factor permit fees into their overall budget. We have exposed the panel count trap and the financing trap. Now, a deeper trap waits in the battery room. The reality of battery replacement is our next micro loop. Batteries are consumable capital equipment that degrade over time due to cycling, temperature, and operating practices. The National Renewable Energy Laboratory explicitly defines degradation as a decline in performance over time and charge cycles. A home buyer should not accept a generic statement such as the battery lasts 10 years. They need exact details before buying. This includes the model number, battery chemistry, nameplate specifications, and usable kilowatt hours. Buyers must also verify warranty duration, end-of-life retained capacity, cycle limits, and throughput limits. Temperature limits and warranty exclusions must be clearly defined. Look closely at labor reimbursement, shipping, disposal, and reinstallation coverage. Clarify whether the warranty covers the battery alone or the entire integrated system. Determine if replacements are like for like, prorated, cash equivalents, or subject to product availability. Warranty language matters deeply. A battery warranty can allow meaningful capacity loss before it expires. That matters more off-grid than in a grid-tied backup setup. Lower usable capacity narrows the household margin during poor weather. A home buyer should ask a critical question at year 10. How many usable kilowatt hours does the written warranty guarantee under my intended daily operating pattern? The inverter is another potential bottleneck. The Department of Energy Operations and Maintenance Guide says photovoltaic module warranties can reach up to 25 years. Inverter warranties often cap out at 10 years. A buyer might see a 25-year panel warranty without budgeting for inverter maintenance. That mistake compares the longest-lived component with the lifespan of the entire system. EnergySage estimated in July 2026 that a typical installed home battery costs $15,647 before incentives. That price delivers 13.5 kilowatt hours of storage. This is a general market estimate and should not be treated as an exact installed price. The EnergySage off-grid guide states that an off-grid solar plus storage system for an average house often costs $115,000 or more. It contrasts that figure with lower-cost equipment kits. Complete home systems include considerably more than just a panel and battery package. An industry estimate published in February 2026 lists illustrative installed off-grid ranges. A small system with 3 to 5 kilowatts of solar and 15 to 25 kilowatt hours of battery costs $15,000 to $30,000. A medium system with 8 to 12 kilowatts of solar and 40 to 60 kilowatt hours of storage ranges from $35,000 to $55,000. A large system with 15 to 20 kilowatts of solar and 80 to 100 kilowatt hours of battery costs $60,000 to $100,000 or more. These figures are private sector planning ranges, not government benchmarks. They do not represent a verified national average. But macro loop titans, you have seen the engineering gaps and the financing traps. Now you face the truth about generators. Including a generator is not a sign that solar power failed. It is frequently an intentional engineering safeguard. The Department of Energy Small Wind Off-Grid Guide notes that hybrid solar, battery, and generator systems provide reliable power around the clock. Battery banks are commonly sized for 1 to 3 days of electric load. In a true off-grid system, a generator is a rational tool for multi-day storms and seasonal low sun. It helps during unusual household demand, battery recovery, equipment failure, and temporary construction loads. It also protects against fire season smoke and snow-covered panels by preventing deep battery discharge. The Department of Energy describes a scenario where prolonged cloudy weather triggers a propane generator when battery charge falls to a set threshold. In that example, the generator charges the battery rather than directly powering the whole building. The hidden question involves generator fuel logistics. A backup generator requires far more than just the machine itself. Consider fuel choices like propane, gasoline, diesel, or natural gas. Storage capacity and delivery access during storms are critical. Fuel aging poses a major risk, particularly with gasoline. You must plan for an exercise schedule, oil filters, and routine service intervals. Noise, sighting, carbon monoxide safety, and automatic start configurations also demand careful attention. Pay close attention to generator power ratings and battery charging efficiency. Department of Energy Tribal Case Material contains a critical safety instruction. Never operate a generator indoors, including in homes, garages, basements, crawl spaces, or partially enclosed spaces, even with ventilation. A transparent contractor should quantify expected generator reliance. They must detail expected generator hours and fuel gallons per year. Detailed records should provide the design weather year or solar data source along with the assumed load profile. Ask what state of charge threshold triggers the generator start. Check whether the generator can cover home peak loads, charge batteries, or handle both simultaneously. Find out what happens if the generator fails or fuel delivery becomes impossible. Without these figures, an off-grid claim may be technically true, but operationally incomplete. The common enemy here is the silence around generator dependence. Sales pitches show panels and batteries, while contracts often omit fuel tanks, propane deliveries, maintenance schedules, noise, and carbon monoxide risks. We have opened the generator loop. A final loop closes the trap. That loop is safety code permitting and insurance. Off-grid does not mean unregulated. A system disconnected from the utility grid can still require building permits, electrical permits, and structural reviews. It may need fire code review, zoning approval for ground mounts, and battery-specific compliance inspections. Homeowners Association approval and insurance underwriting reviews may also apply. The Federal Trade Commission advises homeowners to check whether a company holds required state, county, and city licenses. A state may specifically require an installer to hold an electrical contractor license. Consumer advocates also recommend comparing detailed bids that include building and electrical permit fees. The Department of Energy Community Solar Guide notes that local building departments commonly inspect and approve systems before operation. Some jurisdictions require fire safety inspections as well. Utility interconnection might not apply to an off-grid project, but local approval still does. Consider photovoltaic fire safety and rapid shutdown rules. The Department of Energy states that since 2014, the National Electrical Code has required rapid shutdown systems for building-mounted solar modules. Implementation and local adoption can vary widely. Ground-mounted systems may be treated differently. Article 690.10 identifies fire mitigation planning for certain photovoltaic configurations without circuit interrupters. Keep this important nuance in mind. The National Electrical Code is a model code. Local and state adoption versions, amendments, and enforcement differ. Every project must be verified against its local authority having jurisdiction. Battery safety requires equal scrutiny. The National Fire Protection Association identifies stationary energy storage systems as requiring specialized safety measures, particularly with lithium-ion technology. Key standards include National Fire Protection Association Standard 855 for stationary energy storage systems. Other crucial standards are National Fire Protection Association, Standard 70 for the Electrical Code, and Standard 1 for the Fire Code. Residential guidance outlines rules for energy storage systems in the 1 kilowatt-hour to 20 kilowatt-hour range. The National Fire Protection Association specifies maximum stored energy locations. Utility closets and storage spaces are capped at 40 kilowatt-hours. Attached or detached garages, exterior walls, and outdoor installations are capped at 80 kilowatt-hours. Approved installation locations include attached or detached garages and exterior walls located at least 3 feet or 914 millimeters from doors and windows. And unfinished room housing. A storage system requires walls and ceilings protected by at least 5/8 of an inch or 16 millimeters of gypsum board. Interconnected smoke alarms are required throughout the home. When an energy storage system sits where a smoke alarm cannot go, like an attached garage, a connected heat detector is required. Applicability depends entirely on adopted local codes. A buyer can ask about several key standards. Underwriters Laboratories Standard 1973 covers stationary battery safety. Standard 1741 covers inverters and distributed energy equipment. Model 9540 applies to energy storage equipment. Standard 9540A tests fire propagation and thermal runaway. Buyers should also reference National Fire Protection Association Standards 70 and 855. These standards do not guarantee absolute safety on their own. However, they provide buyers with a concrete due diligence checklist. The macro loop is nearly closed. You have seen the engineering, financing, generator demands, and safety codes. The final piece is the due diligence checklist that turns these secrets into leverage. First, we must confront the remote power case where off-grid solar is a survival necessity. The remote power case changes the stakes entirely. This is not a lifestyle purchase. It is essential infrastructure where grid extension is unavailable or prohibitively expensive. The Department of Energy reports that diesel-generated electricity in many remote Alaska communities has ranged from 50 cents to more than $1 per kilowatt-hour. Larger, less remote locations range from 19 cents to 37 cents per kilowatt-hour. These numbers rewrite the economics of energy independence. In Hughes, Alaska, the Department of Energy reported in February 2019 that the native village of Hughes installed a 120 kilowatt solar system. It was paired with about 120 kilowatt hours of lithium-ion storage. The system was expected to allow diesel generators to turn off during summer. It promised to save approximately $54,000 per year in fuel, totaling over $1 million across 20 years. These were projected outcomes at publication time, not confirmed lifetime results. Nationwide, tribal households face an energy burden 28% above average. An estimated 17,000 tribal homes lack electricity, affecting at least 54,000 people. Off-grid solar is an essential infrastructure solution for these communities. The common enemy shifts in remote settings. It is not a deceptive salesperson. It is the raw physics of remoteness, the cost of fuel delivery, the vulnerability of a single generator, and the silence of a village when fuel runs out. The Hughes case reveals a critical design truth. The system was not panels alone. It was an engineered hybrid of solar, battery, and diesel power. The Department of Energy states that microgrids range from single customer systems to networks with hundreds of generators. Many electrical generators require an external battery to start, much like a car engine. The Mount Rainier National Park case study illustrates the same hybrid approach. A system installed in 2017 recommended a propane generator and deep cycle batteries for 2.5 days of storage. The project was custom designed for a remote site, not a standard home. Here is the micro loop that traps suburban buyers. They see remote success and assume the technology scales down effortlessly. It does not. A remote system is engineered for a specific load profile, solar resource, and fuel logistics chain. The suburban off-grid dream often ignores that fuel logistics chain entirely. A Department of Energy tribal energy planning document states that an off-grid system may include solar panels, a controller, an inverter, and a battery bank. When consumption exceeds solar output, energy comes from batteries. When photovoltaic output exceeds use, batteries charge. It warns that off-grid sizing is critical because electricity supply is interrupted when batteries are depleted. It says a backup prime power source is often an engine-driven generator and can add 10% to 20% to system cost. This figure comes from an older planning document and should be labeled as historical project context guidance, not a current national cost rule. The escalation is clear. The remote village accepts the generator as a non-negotiable partner. The suburban buyer is sold the generator as a failure of the solar. That misalignment is where resilience dies. Now the macro loop demands the solution. If the engineering is this complex, the financing this opaque, the generator this essential, and the code this persistent, how does a buyer survive the process? The answer is the buyer due diligence checklist, but the checklist is not a comfort. It is a weapon. Consider design proof. Provide 12 months of actual load data and a line item appliance load schedule. State daily kilowatt-hour assumptions, annual kilowatt-hour assumptions, and peak kilowatt surge assumptions. Provide month-by-month photovoltaic production, not only annual production. Identify the solar weather dataset and location used. Show worst month energy balance and expected generator runtime. Specify days of autonomy at present battery capacity and at warranty end battery capacity. Indicate which loads are backed up, restricted, shed, or prohibited. Regarding equipment proof, list exact panel, inverter, charge controller, battery monitoring, and generator model numbers. Detail battery nameplate kilowatt hours, usable kilowatt hours, continuous kilowatts, peak kilowatts, chemistry, warranty duration, and end of warranty retained capacity. Enumerate inverter continuous and surge ratings. Outline expected replacement periods and replacement cost assumptions. Explain generator fuel storage, consumption, maintenance, and automatic start logic. Confirm listed certified equipment standards where relevant, such as Underwriters Laboratories 9540 System Certification and Underwriters Laboratories 1973 Battery Certification. For cost proof, separate cash price from finance price. Disclose dealer fees, lender fees, platform fees, program fees, origination fees, and any interest rate buy-down. Specify annual percentage rate, term, total of payments, lien security interest, and prepayment terms. Itemize permits, trenching, site work, electrical upgrades, structural work, battery installation, generator fuel storage, monitoring, and tax administrative costs. State whether projected tax credits are included in payment illustrations. Require a contingency budget for battery, inverter, and generator replacement. Regarding legal and safety proof, identify permit jurisdiction and permit numbers. Determine applicable electrical, building, and fire codes, along with inspection requirements. Confirm contractor and electrical license status, insurance, and bonding as required locally. Verify battery location clearances, smoke and heat detection provisions, and vehicle impact protection where needed. Obtain fire emergency labeling and shutdown instructions. Do not operate generators indoors or in enclosed or partially enclosed locations. For contract proof, require an exact scope of work. Demand a commissioning acceptance test. Ensure written documentation of what off-grid capable means is included in the contract. Request a service and escalation contact. Obtain performance and equipment warranty documents before final payment. Avoid high-pressure signing, free solar claims, and immediate payment demands, consistent with Federal Trade Commission warnings. This checklist is the only way to close the macro loop, but there is a final twist. The most competent design is less about viral self-reliance and more about conservative engineering. The best off-grid systems are boring. That is the final chapter. Indeed, saying that the best off-grid systems are boring sounds like an insult. It is actually the highest engineering compliment. Viral self-reliance chases the aesthetic of independence. Conservative engineering chases the physics of survival. The gap between them is measured in frozen pipes, dead batteries, and generator fuel bills that rival a mortgage. Consider the details. Detailed load study, seasonal modeling, battery reserve, load shedding, generator backup, code-compliant battery placement, monitoring and service, and clear warranties. These are not sexy bullet points. They are the difference between a home that works in January and a home that goes dark when the temperature drops below zero. The Department of Energy Sizing Framework demands this boredom. National Fire Protection Association Battery Guidance demands this boredom. Federal Trade Commission recommendations to verify licenses and obtain detailed bids demand this boredom. The common enemy hates boredom. Boredom does not sell viral videos, nor does boredom close high-pressure deals. Boredom requires math. Let us look at the math that boredom protects. The National Renewable Energy Laboratory states that battery economics are affected by degradation over time. Degradation management can extend battery lifespan. Its residential battery study found optimized control strategies produced more than a 50% decrease in capacity degradation and more than a 10% average reduction in operational costs for modeled scenarios in Fort Collins, Colorado, Phoenix, Arizona, and Portland, Oregon. This is a modeling result, not a universal promise for every system, but the principle holds. A battery managed with conservative depth of discharge limits lasts longer. A battery cycled to zero every night dies early. The sales pitch rarely mentions depth of discharge. The warranty often hides it in fine print. A National Renewable Energy Laboratory 2025 analysis found a median performance loss rate of approximately 0.5% per year for fixed-tilt crystalline silicon systems. Several other categories had medians around 0.75% per year. These are observed category-level values, not warranties for an individual home. Department of Energy Material notes that manufacturer module warranties can reach up to 25 years. Inverter warranties can reach up to 10 years. It gives illustrative module performance warranties of 90% after 12 years and 80% after 25 years. Or linear warranties beginning around 97% in year 1, with approximately 0.5% to 0.7% maximum annual degradation. Warranties vary by manufacturer and contract. The narrative point is brutal. 25-year panels do not mean 25 years of zero cost, zero maintenance, identical output, whole system service. It is a module life statement, not an off-grid system life statement. The inverter is the silent killer of the 25-year dream. A Department of Energy Operations and Maintenance guide says photovoltaic module warranties can be up to 25 years, and inverter warranties up to 10 years. A buyer who sees a 25-year panel warranty but does not budget for inverter or control system maintenance is comparing the longest-lived component with the lifespan of the entire system. 10 years, that is the inverter horizon. It is also the battery horizon for many chemistries. The generator major overhaul horizon arrives at 10 years as well. The 25-year panel sits on a roof, watching 3 generations of electronics die beneath it. This is the climax of the macro loop. The independence illusion shatters on the rock of replacement cycles. The financed price includes dealer fees that vanish into the lender pocket. The tax credit requires tax liability you may not have. The generator requires propane you cannot get in a blizzard. The code requires a fire-rated room you did not budget for. The buyer due diligence checklist is the only shield, but a shield is heavy. Carrying it requires discipline. Most buyers drop it at the first sign of a smooth salesman. We have built the case. We have shown the traps. We have defined the boring path. Now we must answer the final question. When is off-grid solar the rational choice? The answer separates the lifestyle tourist from the infrastructure builder. That is the final chapter. When is off-grid solar the rational choice? The answer is not found in a suburban backyard chasing a $0 bill. It is found where the grid does not exist, or where the grid costs a fortune. Department of Energy reports indicate that diesel-generated electricity in many remote Alaska communities has ranged from 50 cents to more than $1 per kilowatt-hour. Tribal households nationwide face an energy burden 28% above average. An estimated 17,000 tribal homes lack electricity, affecting at least 54,000 people. In Hughes, Alaska, the native village installed a 120 kilowatt solar photovoltaic system with 120 kilowatt hours of lithium-ion storage. Projected savings are $54,000 per year in diesel, totaling over $1 million over 20 years. The generator is not a backup there. It is a partner in a hybrid microgrid designed for survival. Contrast that with the grid-served suburban home. The utility offers reliable power at a fraction of the off-grid capital cost. The sales pitch sells independence. The engineering delivers a power plant that demands daily management, fuel logistics, and replacement reserves. The common enemy is the lie that these two scenarios are the same product. They are not. One is infrastructure. The secondary option is often an expensive hobby disguised as a hedge. The macro loop closes here. A roof covered in panels looks like freedom. The reality is a power plant you must engineer, finance, fuel, maintain, and permit. The secrets installers pray you never find out are not secrets at all. They are physics, economics, and code, written in manuals you did not read. The most defensible off-grid system is boring. It has a detailed load study, seasonal modeling, battery reserve, load shedding, generator backup, code-compliant battery placement, monitoring, and clear warranties. It has a cash price separated from a financed price. It has a contract that defines off-grid capable in writing. If you want that system, you will pay for it twice. Once in capital and once in discipline. That is the price of true independence. Everything else is just a lease on someone else's power plant.